We're going to continue in the first section of chapter 4. And now that we have these basic rules, we're going to talk about how we actually use them. There are not a lot of basic rules with integration, so we are a little more reliant on our algebra ability to help us with this process. So I want to take you through ones that are very similar to what I did the first day that we learned how to derive, which is looking at ones that have to be rewritten so that we can see how we use that power rule for integration, integrate it, and then see if there's any simplifying necessary at the end. So the rewriting that you're going to notice is going to be a lot of negative exponents, a lot of rewriting radicals, and a lot of exponent rules. So for the first one, we have 1 over x to the third. We're going to rewrite that as x to the negative third. If you forget to write the little dx at the end, it's not a big deal. That's just reminding you what variable you're working with. And then our power rule for integration, remember it's the opposite of the derivative, so you kind of have to keep everything straight in your head. It's power 1 greater divided by that power. And then in the last column, two things you want to do in the last column. First of all, get rid of anything that's a negative exponent. And second, make sure you have a plus c at the end of your answer. So you end up getting negative 1 over 2x squared plus c. The negative can go anywhere. It can go on the top, on the bottom, or out front. The next one, you want to use your radical rules for rewriting as exponents. So that's going to be power over root. So fifth power over third root. So then power 1 greater would be 8/3. So you have x to the 8/3 over 8/3. We don't want to really get in the habit of writing it as a fraction over another fraction. So what you do to clean this one up is you multiply by the reciprocal of what's underneath. So you get 3/8 x to the 8/3. After you do a few of those with the fraction ones, they get a little more comfortable and you probably can skip steps and go right to the answer. Next one is in the bottom and it's under a radical, so we got to do both cleaning up here. So it's x to the negative power because it's in the bottom, and it's going to be 1/3 because it's under a cube root. So power 1 greater than negative 1/3 is positive 2/3 divided by 2/3. Again, we don't want to leave it in that complex form, so we're going to multiply by 3/2 instead, x to the 2/3, and again, put the plus c. I did test out on Delta Math. If you put a plus c with a capital C or a plus c with a lowercase c, they give you credit for either one. I was kind of messing around and just seeing like what are they looking for as far as forms. They don't care if you go to like a radical form or a fraction form. You do have to have some version of plus c, and they do expect that you reduce fractions if possible. So the next one has an x on the bottom, and it also has an x to the 1/2 on the bottom. So you're going to have to add exponents. So this is using exponent rules. So you get x to the 3/2, but because it's on the bottom, you want to write it as x to the negative 3/2 when you rewrite it. So using our exponent rules from Algebra 1, using our negative exponent, so power 1 greater is going to be x to the negative 1/2 divided by negative 1/2. Multiply by the reciprocal on the bottom, we get negative 2. And then x to the negative 1/2 is going to be on the bottom, so x to the 1/2 plus c. And then finally, the last one, you're going to want to subtract exponents. So you have an x to the 5th over x to the 1/2. So you're going to do 5 minus 1/2, which is 4.5 or 9/2. So that is my rewritten version, x to the 9/2. It's a messy 9. And then power 1 greater would be x to the 11/2 over 11/2, which can be rewritten as 2/11 when I multiply by the reciprocal, x to the 11/2 plus c. So now the last two slides, I want to just talk about some of the algebra that you will need to utilize in order to integrate. We don't have product rules for integration. We don't have quotient rules for integration. So we don't really have a backup plan other than algebra has to be our guide. So when we have something that can be simplified with algebra, it has to be done before you do any sort of integration. So the first one, I call this pretzeling. You've heard me say that now a little bit since the year started. I split it up into 3 fractions. So my first one, get rid of that writing so it's not in your face just now that you see it. So my first part of the pretzel is going to be x. Second part of the pretzel is going to be 2. And the last part of the pretzel is going to be 5 over x squared, which I'm going to write as 5x to the negative 2. So splitting it up into 3 pieces with all of them over the denominator. So then the integral of x is x to the second over 2. The integral of 2 is 2x. And the integral of 5x to the negative 2 is 5x to the negative 1 over negative 1. Please don't leave the negative exponent in your answer, so you get x squared over 2 plus 2x minus 5 over x, and then don't forget your plus c. You will probably forget your plus c once or twice in delta math, and after you do it a couple times, you'll start to get annoyed that you had to redo the problem and hopefully start remembering them. It will not give credit if you don't put a plus c at the end. Excuse me. Next one, you're going to want to distribute before you integrate. So when I distribute, I get 2x to the fifth plus 5x to the fourth minus, excuse me, minus 7x cubed. Then I'm going to integrate each piece. So I get 2x to the sixth over 6 plus 5x to the fifth over 5 minus 7x to the fourth over 4. Clean up your fractions. So we have x to the 6th over 3, or you could write it as 1/3 x to the 6th plus x to the 5th minus 7/4 x to the 4th, and then plus c. So distributing, pretzeling, all really helpful algebra techniques. The last two are going to be foiling and squaring. So again, a lot of basic algebra 1 really helps us do complicated calculus. So this next one we're going to foil. So my first is 12x squared. My outer is 10x. My inner is negative 24x, and my last is negative 20. And quite possibly you could just do those two things in your head to save you a little bit of time. And then we're going to integrate term by term. So power 1 greater divided by that power. If you notice that you can simplify it ahead of time, go for it. Power 1 greater divided by that power minus 20x plus c. I am going to, they do expect on delta math that you put your answer in simplest form, just meaning reducing fractions. On the AP test, if you don't, you'll still get full credit. But I don't want you to have to redo a delta math because you forgot to reduce a fraction. And then the last one, you have to square it out. So you can either write it off to the side and foil it, or if you're comfortable squaring it out in your head, that's fine too. When you square it out, you get 9x to the fourth minus 12x squared plus 4. Again, if you're not comfortable doing that in your head, by all means, put it out, write it twice and foil it. Biggest thing is make sure you get the algebra right. So now when I integrate, we get 9x to the fifth over 5 minus 12x to the third over 3 plus 4x. And the only thing that will simplify is this middle term. It will become a minus 4x cubed. You'll still have a plus 4x, and don't forget your plus c. Here's the nice thing about all of this. When you get to the end of your answer for anything we've done today, if you derived it, you end up right back where you started. So because we now know how to go both directions, we can derive and we can integrate, you have the ability to check everything you do now because everything you integrate should derive back to where it started. So it's nice that it kind of works hand in hand. And that gives you a basic introduction to what you're going to have to do on Delta Math for the basics of integration.